Hi everyone, you are here with me, Dr. Patamaporn or Ajahn Mae-Naew from the Department of Electrical Engineering, Faculty of Engineering, Kasetsart University in Bangkok. Okay. Well, today's clip we are going to be looking at the topic of total resistance and Ohm's law. So let's start with the topic of total resistance. Okay, so when there are sort of like two ways to connect your resistors. One is in series and one is in parallel. Of course, you can combine them together, series and parallel mixed together in a circuit. So let's start with series connection. Okay, series connection. So have you ever asked yourself what is the definitions of when things are connected in series? Right? We normally say, okay, I can see it, this is in series. Okay, but there is actually a definition to it. The definition is that when things are connected in series, okay, the current, if there's a current flows, the current that flows through those elements connected in series would be the same. That's the definition of things connected in series. Okay. I will jump right into the formulas for total resistance. If you want to find a total resistance here, RT, total, okay, looking into the direction of this arrow right here, the definition is simply R1 plus R2 plus R3. So this is the formula for total resistance when you connect resistors in series. So let's look at an example. So let's say that I will have R1. I assign R1 equal to 1 k ohms. R2 equal to 4.5 k ohms, and R3 is equal to 10 k ohms. Of course, k means 10 to the 3, right? So it's 1 times 10 to the 3 ohms. This is 4.5 times 10 to the 3 and 10 k ohms, like that. Okay. So, well, if you calculated this R total, it would be simply 1 k ohms plus 4.5 k ohms plus 10 k ohms. So therefore, your total resistance is equal to 15.5 k ohms, right? Using your calculator or your head, up to you. And this is your answer. So now I'm going to show you with the actual resistors, okay, that the values is as the theory said, doing the experiment for you to show you, okay. Okay, ทีนี้ all right, so hi. So let me introduce to you some of the equipment that you need to use to play around with electric circuit. Well, this is called the DMM, digital multimeter. It can act like a voltmeter and ammeter and ohmmeter also. These are the most of the things that we use for. It has two probes, right here, the red one and the black one. The red one, we use it to actually point it, measure at the positive terminal of the voltage drop, and the black probe is for the negative terminal of the voltage drop in the circuit. Okay. Now, it can measure, as you can see, volt right here, right? Both the direct current and alternative current, DC and AC, in volt unit, in millivolt, right? It can measure ohms, the resistance values. It can measure the current, right, in microamp, milliamps, and ampere. And of course, the signal, the sign right here, that means that it can measure in DC and AC signal. Okay, so first of all, I'm going to show you the measurement of the resistance. Okay, so therefore, we put the black probe where the common is, and the red probe where there is an ohm sign. You can see there's an ohm sign right there. Okay, and I'm going to turn this, right? It should be off all the time if you don't use it. And we're going to move it to ohms, right? The sign right there, right? The omega sign, okay, for the unit of ohms. All right, so from the problem, okay, so and I have here breadboard, right, and resistors, like what I gave you an example right now, right? R1, R2, R3, right? So we say that R1 is 1K, R2 is 4.5K, and R3 is 10K. So let's measure that. Okay, so I'm going to measure that right now. So let's see. So R1 is supposed to be 1K ohm. So let's look at the screen, the monitoring things, and 0.98. Of course, all these resistors have tolerance. It's not exact values, you know, it can be plus minus 10% or plus minus 5%, depending on how much you're paying for it, you know, things like that. The R2, we said is 4.5, right? So 4.5, let's see, let's measure that, 4.5. It's like 4.8, 4.89. We got more than what we bargained for. And the last one is 10K ohms. So let's look, 10K ohms, 9.9, right? 9.9. So these are the three individual ones that I have selected. Now we say that our total, when we calculated, right, it's R1 plus R2 plus R3. And the result was, how much was it? 15.5 kilo ohms. Hopefully, when I measured the R total, it would be about 15.5K. So let's look. Right there. Okay, 15.7K ohms, okay? So that proves that what I just said about in the theory, when we do it, set it into in action, it's true. Thank you.